All right, so a couple more examples of solving by the quadratic formula, but where it doesn't turn out pretty, like the first example we did. So if I do the quadratic formula here, x is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you're using your calculator on this, be super careful on this. Really. Be super careful on this, because remember, if you don't put the -6 in parentheses when you square it, it's going to give you -36, when that is in reality 36. So do be careful on that. But we know that this is 36, plus 16 all over 2. So that's 6 plus or minus the square root of 52 all over 2. Now 52 is not a perfect square. Like the last example we have where 100 was. So we're going to take the 52, and we're going to bracket break it down. So let's see, that's 2 and 26, 2 is prime, 2 and 13, 2 is prime, so it's 13. So I would write this down. And then square roots look for pairs of like factors, because they're looking for perfect squares. I've got a pair of 2's, so that means I can pull a 2 out in front. Now when you put the 2 in front, be careful, it goes directly in front of the radical. So stay there, like that. So we've done the quadratic formula, we've simplified the radical as much as possible, and now we need to see if the fraction can be simplified. Now remember, only outside numbers interact with each other. So this 6, this 2, and this 2 here are all outside, right? If they all have a common factor, then the fraction is not fully simplified. Those all have a common factor of 2. So I'm going to take the 2 out of all of them and cancel it. So that will give me 3 plus or minus 1 square root of 13 all over 1. Because I canceled the 2 out of all those things that run the outside. So basically, this is 3 plus or minus the square root of 13. Now, when you simplify something and you have the radical still there, this is what's called the exact solution. Because the square root of 13 is a decimal that goes on forever. If I actually turned it into a decimal, it would be called an approximate solution. So exact solution, when I mention exact solution, I want it with still the radical in it. If I wanted an approximate solution, say rounded to the hundredths, that's where I would pull my calculator out and say, what's 3 plus the square root of 13? What's 3 minus the square root of 13? So I'm going to pull up my calculator here, and I'm going to do 3 plus the square root of 13. That is 6.605, so when I round that, that's 6.61. And then 3 minus the square root of 13 is negative 0.605, so negative 0.61. So approximate means I want the decimals that the square roots are equal to. You have to have a calculator available for that. Exact means I want the radical still in it. Okay? So there's 2 Alex topics there. One of them is using the quadratic formula where you're finding exact solutions. One is where you're finding approximate solutions. Now, I want to look at this second one. So starting with the quadratic formula, negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. So we get negative 6 plus or minus the square root of 36 minus 48. I think you can see where I'm going here. This ends up being negative 6 plus or minus the square root of negative 12 all over 2. Now, back in Algebra 1, when you got something like this, you would say, oh, we can't take the square root of a negative number. There's no real solutions. Technically, that's true. There's no real solutions. But now we know about complex numbers involving I. So whenever you see a square root of a negative number, we need to use the i's to simplify it. So, got negative 6 plus or minus. Remember, square root of negative 12 is the square root of negative 1, which is I, times the square root of 12. 12 can be factored. That's a 4. So 3, 2, and a 2. So I could pull a pair of 2's out in front as a single 2. And then I look at all my numbers outside to see if there's a common factor, and there is. So I want to take that 2 away from all of them. So in this case, it's negative 3 plus or minus I square root 3. Now, you'll never be asked to give an approximate solution when there are imaginary numbers involved, just exact. So this is the form I'm going to want it in. So now you know how to solve the quadratic formula, even if it doesn't turn out as a pretty answer.